Hello friends, welcome to part 2 of our machine learning the future course. In the previous module, we have seen the machine learning classifications, which is supervised and unsupervised, and here we are with the regression, which is one of the type of supervised machine learning. So what is regression in machine learning? Regression is one of the most important and widely used machine learning technique. It allows you to make predictions based on the data, which is features of data and the continued values response. So as we have seen in our data preprocessing module, there are independent and dependent variables. So X, which consists of the independent variables, is known as matrix of features, and Y, which consists of the dependent variables, is known as vector of dependent variable. So what regression does, it learns the correlation or relationship between X and Y, and then if we provide any kind of a training set to a machine learning model, it will predict the outcome, which is Y, the dependent variable. So that is our main aim of building a machine learning model. First of all, letting the model to learn based on our providing data set, and then we'll test the data set with our own values, and then we'll try whether it is able to predict the value, which is Y, which is the dependent variable. So let's look at types of regression. There are various types of regression, which is simple linear, multiple linear, polynomial, decision tree, SVR, and random forest. So our main aim, as I already stated, is initially we'll provide a data set to a machine learning model, which includes both X as well as Y, as this is a supervised machine learning, which includes both inputs and outputs. So we'll provide our machine learning model with X as well as Y, and then we'll create a test set which will test our machine learning model to predict the values of the dependent variable, which is to predict the output out of it. So let's start with the simple linear regression. So simple linear equation. What is the equation of a line? Y is equals to mx, as you already learned in your basic mathematics course. So simple linear regression works on that principle. Y is equals to m0 plus m1 into x1, where y is the dependent variable, m0 is a constant, m1 is a coefficient, and x1 is your independent variable. So if you plot this equation of a line on a graph, we'll see it like this. So there will be multiple points over here which will be able to plot a line out of it, and this initial point is the constant, which is m0, and this is the slope of a line, which is y upon x. So m1 is the slope of a line. So simple linear regression resembles in this manner. So there will be multiple points in a graph, and our regression model or our simple linear regression model will create a regressor line like this, which will predict the values based on the input which you have provided. So this technique works on ordinary least square. But what do you mean by ordinary least square? So here we are. If you can see, the orange observations are the actual observations, and the observations which are green is a modeled observation, which is here. So what will we do is, here in the dotted lines is the difference between these two values, which is the regressor or the modeled observation, and this is the actual observation. So what we do is we take each of those green lines, or you can say this blue lines over here. We take each of those blue lines and you square them. So sum and the squares. So what this ordinary least square method does is, it takes the distance between the actual observation and the modeled observation, and it squares it. So y minus y cap, as you can see enlarged over here, it takes the distance or the difference between the points, it actually sums them, and it takes the minimum out of it. So what the simple linear regression does is, it draws a lot of lines over here, and it takes the line which is having a minimum of sum of the square of the distances. So that line which is the best perfect match will be the line which has the minimum of sum of the squares. So that is our ordinary least square method, which is useful in determining the simple linear regression line over here. Now, as you can see, why are we doing this? So why are we actually building out a model, machine learning model, using regressor or any kind of these techniques? So let's say this is a data set of our machine learning simple linear regression model, wherein you have experience as well as the salary with respect to it. So a person having 6 years having $93,000 salary, similarly a person having 10.5 years having $12,000 salary. So there will be a demand, or there will be kind of a way wherein you need to present a business model which will best fit out of it. So find out the best fit business model or the best fit relation out of this data set. So at that time, what will you do? You'll be using a machine learning model to create it. So a best fit correlation between experience and salary will be obtained by a machine learning model based on linear or polynomial or any kind of different type of machine learning model. So there will be a best fit relation and model which will help us to carry out our business expectations out of it. So if you want to judge what is the actual salary of a person having experience of 5.5, so our machine learning model will help us to identify an approximate value which will be the best fit and which will help us to find out a more better correlation between salary and experience. So this is the reason why we are doing all this. So till the next time, I hope you liked the video. Thank you very much. Goodbye.